Hi, Craig Wilkins, President and CEO of ViZn Energy. A lot has happened over the last 6 months as we've prepared for our commercial launch of our grid-scale storage system. Formerly Zinc Air, we have changed our name to ViZn Energy to better reflect the technology as we move into the commercial market space. Vision has a very specific connotation to it, and that is the ability to see into the future of what will be or what will come to be. And we truly believe that energy storage is the future and that we're a critical part of that. In addition to the name change, a lot of exciting things have happened around here. Number one, we've beefed up our team. Our technology continues to make strides and huge improvements. And really our market, our go-to-market strategy has become much more refined, and which has allowed us to see a lot more success in that area. So let's talk a little bit about the team. We've added Paul Silberrud, Senior Vice President of Marketing and Strategic Alliances, to help us guide our process through this commercial launch and allow us to better position our product into the market. In addition to Paul Silberrud, many of you may know John Lowell has been here for quite a while, but we've elevated him up to our Chief Operating Officer to better reflect the role that he has taken and the leadership he has shown in the company. He's done an outstanding job getting the product ready. He's going to do an outstanding job making sure that our team works well together and execute upon our overall game plan and strategy. We have found that the microgrid market space is an ideal solution for our battery, and our battery is ideally suited for that specific market. The importance of this is we can provide the same quality of power at a much lower cost and provide the type of returns that our investors would be looking for. Now, with regards to the product, we are making the final refinements to our technology so that it will meet the reliability and performance standards expected from our customers. We're extremely excited. Last 6 months we've improved not only the power but also the energy by over 30% of our battery technology, and we continue to see further improvements ahead of us. I'll introduce John Lowell, our Chief Operating Officer and Vice President of Manufacturing, to give you insight of where we've come and where we're going.
One of the key developments I'd like to share with you that's occurred in the last 6 months has been our work on the full-scale test system. We have been testing full-scale product, what we call our Z20, for approximately 6 months. What you see behind me is our Z20 test bed. This is a product without the container capable of running as many as 4 battery stacks simultaneously. What this has been showing us is the ability to run a multi-stack system off of one set of tanks. This has been allowing us to test all our reliability improvements, design improvements, and output at full scale. The amount of power we're able to get out of this test system is relatively substantial. I'll just show you a prop for a moment. This is a solid copper bar. This is a conductor. This is hooked up to the power conditioning system on this end. You can see the bars on the top. This one, which is a 4-inch bus bar, was too small for the power we're throwing on our test right now. We're now using 6-inch bus bars. So this system is capable of as much as 1600 amps at 60 volts. One of the key pieces to our technology development in the area of reliability and performance improvement has been our electronics package. Each battery we do will have a custom electronics package on it which will manage that battery, will manage the state of charge and report its condition. We are using devices and technology that comes from the electric vehicle market to do that management of the battery. What you're seeing here is an example of this under test. We're doing software development and testing of algorithms at this point on our batteries. What you have is the custom electronics. These are Zinc Air design circuit boards with Zinc Air developed software to run and manage the battery. And what this is doing is monitoring the state of charge on every cell in the battery and it's always tweaking them to keep them balanced, what we call stack active balance. Hence the name that you see on the software screen, the Zinc Air Stack Active Balance. This allows us to monitor that real time, tweak the state of charge on every cell so that they constantly stay in balance. This is a key thing to do to both get life out of the system and get the maximum level of performance over the entire life of the battery. One of the key areas of focus for the last 6 months has been getting our stack performance up. We've been taking all the development on the new technology for the stack, getting it built up in prototype, putting it on test, particularly to test for the effect of shunt currents, dendrite growth, charge migration, cell equalization on the performance of the battery over longer term. What I have here behind me is one of the 3 test beds we use. This is Z15-0. This system has been in essentially steady state operation for approximately 6 weeks now and is approaching 2,000 cycles, charge and discharge of different durations. I will show you some of the data streams coming off the system so you can see for yourself how stable the performance of the system really is. What you are looking at here is the voltage traces off all 30 cells on charge and discharge after approximately 6 weeks of operation. If you see the little blips in the signals there, that is where the electronics is actively taking control and tweaking the charge on the cell to keep them all in balance. You can see this is on charge, on discharge. You can see how extremely well grouped and tight and well behaved the voltage traces are. We are getting tremendous stability after 24/7 testing on the system, and our electronics are showing the great ability to control and manage the effects of shunt currents and state of charge migration on the battery. And now I'd like to show you our first functional Z20. This unit is in our lab in Kalispell. It's grid tied. The grid connection you can see behind me is tied to a local grid for charging and discharging. This system is packaged in a full industrial 20-foot shipping container. It meets ISO shipping standards, so we can ship this by train, rail, truck, or any other method you can ship a container. And now I'll show you the guts of the system. Here's a fully functional Z20 product. We're using it now for system testing, verification of performance for data for ourselves and for our customers, other companies. The main components of this system is, besides the container that is packaged in, I have the 2 tanks, analyte, half-light tanks. These are rotomolded polypropylene, 2,000 gallons each. They are plumbed in with polypropylene plumbing, the standard industrial polypropylene plumbing, into the battery stack. You can see the center behind me. We've got the 2 large pumps that circulate the fluid from the analyte and cathode. These are just standard pumps that get used in the chemical industry and semiconductors for processing abrasive, corrosive fluids. Battery stack, you can see this is a prototype unit under test. It has the control unit in the corner, which is the smart controller for the battery. It contains all the embedded electronics that manage each cell in the battery. The remainder of the embedded control system is here in the high voltage cabinet. This is the electronic system for the control of the speed and the pumps. We have the controller PC, which runs all the software for the control of the system. And then we got the power supply and backup power for the control system on the unit. This whole system is a proprietary design and software by us for control of this system. This unit's under test now. We have this unit here for us. For our testing at Kalispell, we have 2 units, which are going to be done in the next few weeks from our contract manufacturer in Portland. Those will be going out to first customer sites in early 2014.